Disclaimer, disclaimer, disclaimer. We are the most advanced society in the history of the universe. That's right. To the best of our knowledge, you and I are living in the pinnacle of intellectual achievement of any time or place in all of time and space. We have dominated every species that has coexisted with us. We have terraformed the planet to the point of being able to live comfortably anywhere upon it. We have conquered the oceans, mastered flight, taken advantage of the orbiting space, and have landed a man on the moon. And as we gaze out into the near solar planets, we even set our eyes on the prospects of colonizing new worlds, be they the moon or Mars. Truly, we are without equal in terms of ability to impress our will upon the surroundings. Or so we think, until we are less than subtly reminded that there is still one force we cannot control, the Earth itself. And as the Earth churns out travel grounding ash into the atmosphere, we sit and watch, and for a moment can relate to our ancestral beginnings. We can remember a time now of being at the mercy of nature, not the master of it. Still, with each eruption, tremor, or hurricane, we can also be reminded of how far we have come, how much of nature we have learned to master, and how many more discoveries await us on This Week in Science, coming up next.
That sounds bad.
Sounds bad.
I got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new
sounds like my old car
discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening? Sweet in science. What's happening? What's happening? What's happening? Sweet in science.
Good evening, Kirsten.
Good evening, Justin. This is This Week in Science, isn't it?
Yeah.
Yeah. Hey, everyone out there. We are going to be bringing you science news. I'm Dr. Kiki.
And I am Justin.
Hello, Justin, in your
Hello, Dr. Kiki.
in your very nice living room. Congratulations on making the move from the country to the big city.
Yeah, I'm in an urban area now. It's brilliant.
No more cows in your...
No more cows trying to kill me.
I know. What was that? You woke up to cows on your lawn?
That was the other day. There was cows that were like right outside my window that had escaped from somewhere and were trying to get at me. But it was a couple months ago where I was driving down a dark and rainy country road and a cow darted out in front of me and tried to kill me.
I didn't know cows could dart.
It darted. That was a darted cow. They're fast. They're quick. And it was dark. Creatures. It was camouflaged. It was a black cow camouflaged in the night, trying to take me out.
Ninja cow on the move. That's right. Well, anyway, we have a really great show ahead. I don't think it includes any ninja cows or darting cows or anything of the sort. So rest assured, the danger is low. But we have lots of science news, as usual. Science, science, science. I have stories about lightning on Saturn, mitochondrial mutations, or at least getting rid of them, and an abundance of microbes. What do you have, Justin?
I have healthy breasts.
Good for you.
I have a new battlefront that the Pentagon is looking to start waging countermeasures upon. Mm-hmm. Scientists working on this is I got a couple military things for some reason. Office of Naval Research is announcing some cool stuff about some fuel cells that they've developed, and why diarrhea is going to be with you whether you got probiotics or not.
Oh joy. That kind of goes into the first story that I was going to get into, but first, I have an announcement to make, and so we just have to get down to that. I want to remind everybody out there that it is fundraising week at KDVS. KDVS is the radio station that TWiS has called home for the past decade. I can't believe it's been 10 years. But anyway, the past decade, we've been living at KDVS. And KDVS is a non-commercial, free-form radio station. And free-form and non-commercial means that the content isn't determined by commercial interests. It's determined by the people who run the station.
By the actual DJs, even.
The DJs. Yeah, exactly. Yeah. So anyway, I really urge anyone who's listening right now to donate to KDVS in support of what they offer to the community: a voice without commercial influences and a home for science. And so if you go right now,
$0 so far.
I know, right now it's $0.
That's depressing. I give up.
Just for our show. But if you go right now to fundraiser.kdvs.org/premiums /special /show /TWIS and donate $40, you will receive the 2010 TWiS Science Music Compilation CD, which is a special gift that we created just for you generous donors out there. The website again, fundraiser.kdvs.org /premiums /special /show /TWiS. Donate $40, get the annual TWiS CD, and you have the feeling of having done something really wonderful for the world. Yeah. Isn't that nice?
That's awesome. I can shrink my head.
What?
I can shrink my head. Watch.
You can. You're so strange. I don't know what that was. That was something very strange. But anyway, on to the science, right? Did you have a story? I'm gonna bring a story.
Yeah, I do. This is actually my big story this week. Comes right out of the Minion mailbag. This is from Minion Scott, who is foreseeing a new workout show coming to the TWiT Network that every guy will be sure to watch because of the medical benefits. This is a story out of Frankfurt, Germany. The most sensible study that I've ever seen, in fact, which suggests that staring at a woman's breasts is good for men's health and can increase life expectancy.
What?
Yeah, according to Dr. Karen Weatherby, this has all the creds in the world because it was a female researcher. She is the author of the study that gawking at women's breasts is a healthy practice, almost at par with an intense exercise regime that could prolong the lifespan of a man by as much as 5 years.
Wow.
She states that just 10 minutes of staring at basically at cleavage is roughly equivalent to a 30-minute aerobic workout. The research was done on 500 men at 3 hospitals in Frankfurt, Germany. They did the in-depth analysis of 200 healthy males over a period of 5 years, and half the volunteers were instructed to ogle breasts daily, while the rest were told to refrain from doing so. Which I don't know.
Refrain, please refrain from. Excuse me. Please refrain from any of your male tendencies.
Well, but most guys, I think, generally. There we go. I feel healthier already. For those of you listening to the audio versions, that was beautiful. John, our new image DJ there, who's putting it all together, has done a fantastic job at giving us the images to go with the stories. At the close of the story, researchers noted that men who stared at breasts of females on a regular basis exhibited lower blood pressure and slower resting pulse rates and lesser episodes of coronary artery disease.
It's good for your heart.
Since sexual desire is linked to better blood circulation, the researchers declared that the sexual desire gives rise to better blood circulation, and that signifies an overall improved health. So, yeah, I guess those little bits of elevating your heart rate,
it's like exercise, right? You want to just get your heart pumping
it's
a little bit,
or maybe it's 200 little aerobic activities a day. Yeah. See, this is
I don't know.
That can really help us.
I want to find out that the next study needs to be something that's going to look at what can be good for. Is it good for women to look at breasts also? What happens to women? Is there a difference in their physiological state? Is this only men?
Probably a negative. I think
a negative.
Yeah, because women are highly competitive about body image. So we've seen this before, that the effects of looking at models, for instance, lowers a woman's self-image, whereas if she's looking at what would be
but looking at other there's I think
women, raises their self-image. So I have a feeling it would actually potentially nice cleavage could have a negative effect on a.
It could have maybe, but I think there's other research that suggests that that looking at beautiful women, not just the model shape and size, but looking at beautiful women can also be beneficial and have positive influence on women as well. So I don't know if it's all necessarily bad and negative.
And then again, we're all mammals. Like breasts.
And we like to do it like they do it on the Discovery Channel, right?
Well, on this show we do.
Anyway. Oh man, what a good start. Good start to the show. Oh my God. Moving on from breasts to beasts, we've got little tiny bugs, which are microbes. And bet you didn't know that it's even more of a microbial world than you thought. Even more. So the International Census of Marine Microbes is kicked off in 2003, and at that time, they had only identified 6,000 different kinds of microbes. And based on what they had already discovered and what they had been able to put together in culture in the lab as well, they predicted that there would be a maximum of about 600,000 microbes in the world. All right, 600,000. Yeah. Let's up that by about 100-fold. They've now come forward. Magnitudes. They're off by magnitudes. After collecting samples from thousands of sites, 1,200 sites around the world, they combined a database of 18 million microbial DNA sequences, identified hundreds of thousands of different microbes, conservatively estimating that there must be, not maybe, but must be at least 20 million different kinds of microbes. And that's just in the oceans. This is just looking at microbes in the oceans. And that number
look
across...
how cute they are.
They're cute little microbes. Yeah, all sorts of prokaryotes, eukaryotes, whatever. The questions, so Mitch Sogan of the Marine Biological Laboratory at Woods Hole, Massachusetts, who led this project, he says the overwhelming majority of the novel diversity comes from microbes that are rare and present in low abundances. Why are there so many different kinds of low abundant microbes? What roles do they have in ecological processes in the oceans? And so they're kind of thinking that, he says they're basically wild cards and they don't know what they do or how they're going to respond to environmental change, climate change, that kind of stuff. But they think that all these different species could potentially work together to have very niche purposes in the environment. So maybe one species creates a particular compound that another species uses, and maybe they're all very interdependent in a really interlocking Lego kind of way. Another researcher says, Ian Pointer is the chief executive of the Australian Institute of Marine Science at Cape Ferguson in Queensland. He says, we know very little of the microbial world in the oceans. Wherever we look in the oceans, we see a great diversity of life. And with new technologies, researchers have dramatically revised their estimates and improved understanding of the key role of microbes in maintaining the health of the planet. Now, this is a big point as well, because it's been the throughput sequencing. It's gone from low throughput to more recently, very high throughput sequencing of RNA and DNA. And so initially they focused on sequencing an evolutionary conserved gene that's responsible for encoding ribosomal RNA. And they just looked for that gene within seawater. They could only really find the most abundant species as a result of that. But then high throughput stuff came along, and they also found a really rapidly evolving sequence of RNA that they could then look for evolutionary divergence, or so the change from one species to the next. So if you see the mutations occurring in this area of the RNA for this gene, then you can come through, you can basically assume that there's evolution happening and split to different species. And so now they're being able to look at hundreds of thousands of different sequences, and that's just in one day, as opposed to months and years, which they used to have to do. So the big question now is, what are they doing? What are these species doing? Where are they? What's happening? How do we find more of them? They're it's pretty exciting. There was another article published by Randolph Schmidt in the Associated Press, and at the end of his article, he came up with this really interesting interesting calculation. So Census researchers calculate that there are a nonillion microbes in the world. So what is a nonillion? Well, it's 1,000 times 1 billion times 1 billion times 1 billion. And if you can't really get an idea of how big that is, Randolph said he talked to some researchers, and the researchers turned it into a comparison measure, the African elephant.
Huh?
So a nonillion microbial cells is about the same weight as 240 billion African elephants, or the equivalent of 35 elephants for every person on Earth. That's how
Wow.
many microbial cells are estimated.
That
So
each
the
microbial
equivalent.
cell would be making up one of those elephants?
No. That if you
Wait,
were to
what?
add up the equivalent of 240 billion African elephants is the same weight as a nonillion microbial cells.
Oh, yeah. Well,
So if you take all nonillion microbial cells, put them in a big basket and stick that basket on a scale, then you have to put 240 billion elephants on the other side of the scale to balance it.
I don't think we're going to get it to weigh out. I don't think
I don't know.
I don't know. I'm not good at math, but there's probably not that many elephants.
I don't think there are that many elephants in the world. No, 35 elephants for every person worth of microbes. It's huge. Yeah, that's a lot.
And the other thing that would be really interesting to figure out once we start getting into the sort of interactions between the bacteria is we could actually start to locate the ones that don't really seem to do a whole lot and don't affect us in any way, shape, or form, but are good competitors against those that are nasty bacteria. I mean, one of the problems with our antibiotics right now is that they just kind of kill everything and anything. And then we find what we consider to be these really strong, powerful, invasive microbes that do cause us a lot of damage having free reign because we've removed all of their competition. So a really interesting thing in this sort of ecosystem is going to be to find out which microbes really compete against our sort of rogue or not so nice, not so friendly microbes.
And the microbes that aren't so friendly to us, basically. I mean,
because there are plenty of microbes out there that probably control populations of these, antibiotic resistant ones that we've killed off and allowed the ones that can resist. It's not that they're so powerful that they will resist anything. They are probably very weak in the face of microbes that can defeat them and take over territory and take over population.
Right. And a lot of times when you actually see people with bacterial infections, it's usually the result of an imbalance. It's something has occurred systemically so that whatever keeps the system in check and under control has changed. And then you have one species that's able to dominate and come out, and then you have a problem. So, like staph bacteria, they're all over the place. And it's only every once in a while that they end up in a situation that they're able to take over. I mean, you probably have staph bacteria in your nose right now, but they're not necessarily going to give you a MRSA infection because you have a balanced ecosystem. More stories, Justin. Give me science.
To be or not to be? That is the question. And perhaps the cure. Huh? Substance of Hamlet's speech is questioning the purpose and meaning of life. Meanwhile, real-life scientists, unwilling to suffer the slings and arrows of outrageous fortune, have taken their knowledge against the sea of troubles in hopes that, by opposing, they could end them. And in an undiscovered born, new substance was discovered. Human alpha lactobum.
I don't even know what you're trying to say.
I don't know either. Human alpha lactobummin made lethal to tumors, or as is now being referred to, Hamlet. The discovery of Hamlet came to the world by chance a few years ago during a study of breast milk and its antibacterial properties. Since then,
Back
it has
on the
been
breast.
laboratory tested and found to be able to kill as many as 40 different types of cancers.
Whoa.
Yeah. Most importantly, Hamlet kills only cancer cells, does not affect healthy human cells, making it potentially one of the safest treatment solutions imaginable. And it's becoming reality. In the first human testing, patients with cancer of the bladder who were treated with the substance were found to be excreting dead cancer cells in their urine after each treatment, which has given rise to the hopes that it can actually be developed into a medication, potential cancer cure in the future. So far, however, it has been not been proven that the Hamlet complex is spontaneously formed in the milk itself. It may have to be ingested first. So they're still working out to see if
exactly
it's
where it
with
comes
acids or if it's something that happens later on in the process. Researchers at the University of Gutenberg are focusing on how Hamlet can be taken up into tumor cells and how they can perhaps produce it without it having to be, direct from the breast. But that's an amazing cool story. And it's recently been published in the journal PLOS One, Public Library Science Online. So you should, if you're interested, go check it out there.
Yeah, that's the big thing is if it is as good as it seems to be at killing cancer, is it something that you can produce in a laboratory? Do you have to, have breast milk to get it, to be able to isolate it? Or can you actually figure out what it is? Is it a component that's all on its own that you can produce in the lab? And then from there, can you actually produce enough of it to have it be a treatment? And then also not just work in mice in the lab, but work on people. Not cells in a petri dish, not mice, but actually.
And then this was the first term in trial, and they did find that it was killing off cells, that they were finding dead cells. So it has gone that next step out of the petri dish, but they do need to expand that, of course. The only thing is, my concern is this could become one of those economic situations like using corn for ethanols, right, for the biofuels or the agriculturally developed fuels, because in those you were pitting food against fuel, and so because fuel prices are higher than food prices, food gets used for fuel more than it gets used to feed people. I could see a day when cancer cure would pay pretty high compared to a newborn, who might end up being on the powdered stuff instead if mom was selling all the breast milk. But that's the next generation of that problem. Can you imagine that?
Wow, I can't even
imagine the industry. Like there'd be some ethical questions. Because a cancer drug that's just, that's only claim is that it might keep you alive another 3 months can run you $30,000 a month. You get something that's a little bit more effective, but the newborn baby has to go off for a little bit and it'd be trouble.
Yeah. Wow. That's a serious ethical issue. Yeah. Wow. My mind is boggled that you came up with that.
Oh, thank you.
I guess everything's market forces, right?
Yes,
totally.
Yes, it is.
So I was just thinking as we go forward, we've got all these I've had another microbial story that I wanted to cover having to do with carbon fixation and phytoplankton. So the ocean is this giant sink, this carbon sink. And as we look at our planet and increasing carbon dioxide levels in the atmosphere, people are starting to, or have been trying to discover exactly what entails the entire carbon cycle. Where does carbon go? Where does it come from? How is it incorporated into things in the environment? And when it comes to the oceans, it's been pretty well understood that phytoplankton are these little tiny microbes, many, many many different species of them, fix carbon as they grow. It's called a carbon fixation process. So it gets fixed into their tissues. And so there's been a question of what species within phytoplankton actually are responsible for certain amounts of this carbon fixation. And it was thought forever that blue-green algae, or the photosynthesizing cyanobacteria, were the ones who used sunlight to fix carbon dioxide. And it was thought by almost everybody that they were the most important phytoplankton for fixing carbon. But now some researchers at the University of Warwick and at the National Oceanography Center in Southampton, in England, have determined that eukaryotic phytoplankton is really, really important, and they had no idea how important until now. They found that eukaryotic, so eukaryote means having a defined cell nucleus. So we're eukaryotes. We have nuclei in our cells, whereas cyanobacteria do not. They're prokaryotes, or not having a nucleus. And basically, they found that 44% of the total amount of carbon fixation by phytoplankton is from these eukaryotic phytoplankton. That they just were like, oh, they're little tiny cells and whatever, bacteria in the ocean, and not so important. But now they're realizing that they're much more important than they were. And there are two kinds, the euc cells and the euc cells. And the euc cells, they found that euc are more abundant, but they're smaller than the euc, but the euc are the ones that seem to have the larger role in the actual fixation. And they think that it's they don't know exactly why it is, but that's what they think. So the euc are largely comprised of what they call primnesiophytes. I love the names of things. So primnesiophytes accounted for up to 38% of the total primary production in the subtropical and tropical Northeast Atlantic Ocean, suggesting that they play a key role in oceanic carbon fixation. But of course, more research needs to be done. They need to sample more oceans. They need to sample more of these phytoplankton and see what they're doing. They're important. Yeah. I just love like the little pieces of information that, a little study comes out here, a study comes out there, and it's like pieces in a puzzle. You start putting them all together and we find out how important things are or not important, how we might have had a preconceived notion about something that wasn't right just because we think something is some way doesn't mean it is.
Unless I think it's that way, in which case it's got to be that way.
Yeah, whatever.
I think we should go to the
I'll
break.
tend to argue with that.
We should go to the break. We'll be back right after these pretend messages from wherever else we're being broadcast from. And then we'll be right back with more of This Week in Science. Oh, this sounds like a new one.
Disclaimer, whether the universe is made of brains or more like spaghetti in a strainer, we're ready to explain all the secrets of the universe. That is, of course, assuming all the humans don't destroy it first. Human indecence is the doom of our existence, like a piece of pizza microwaved on high for 30 minutes, or a cake you make and shove into the oven overnight. You can smother it with frosting, but it still won't taste right. Science is the chef mixing up the best ingredients. The genius is when it falls within the standard deviance, but even when it doesn't, you can learn from a mistake. Like if you try to bake a pie and instead you get a steak, learning from returns are both important to the mission. If you don't adjust your vision, then you're just a politician wishing some magician can make all the room food disappear. But now I made myself hungry, let's get out of here.
Say that song. Disclaimer. It's by Devo Spice. It's one of the songs on the TWiS 2010 Fundraiser science music compilation. Devo Spice is made up of Tom Rockwell and others. And basically, it's a mix of Justin outtakes from the show. And it's pretty entertaining.
It's pretty sweet. I got mashed up.
You got mashed up big time,
Yeah.
Bucko. It's good.
I got
It's
sampled
good.
and I got cut ups, as bros would say. You did some audio cut ups of me saying some things and jammed them all together.
Some
Pretty hot.
things. Right. Cats. We all love
Ah.
cats, right? Maybe you
Ah.
don't, Justin, but I
Ah.
love cats.
It's a giant cat just
I
here
love
on the
cats.
screen.
Anyway, DARPA likes cats too. And you know how they know? They're funding people to create a supercomputer that is as fast as a cat brain.
Huh?
Yeah, so DARPA has this program they've put together, and they've excuse me, they've funded a bunch of researchers across the country to work on different aspects of creating a mind or a supercomputer that works in the same way that your mind does. So computers are limited by single track processing. They basically can only do one thing at a time. Whereas you and I and our cats can process all sorts of information at the same time. So a cat is actually much better at recognizing a face currently than the fastest supercomputer, a cat brain, and our brain can probably do it at a very nice similar pace as well. And the reason is because it can take in all the different features of the face, and if the face moves, that can be taken into account. The different angles that different features of the face are viewed from. They can all that information can be taken in by your brain or your cat's brain and analyzed to go, oh, that's Justin's face, or oh, that's the face of the person that feeds me. Meow, give me food, human. And so what they're looking at right now is getting a brain, basically like a computer that can work faster and have memory and learning similar to a cat brain. And the cat brain is realistic because it's simpler than a human brain, but still efficient and extremely difficult to replicate. And once they're able to start getting to the point of replicating a cat brain, they'll be that much closer to replicating people. So a recent study was published in Nano Letters by a researcher, Wei Liu, at the University of Michigan, UM. I don't know, Minnesota. I don't know which one. But anyway, he has created a biological synapse, but it's like a biological synapse. He has using memristers, which are one of my favorite new findings of the past couple of years. So we talked about it last week. It's a device that keeps memory even after charge has been taken away. So even if charge is not running through it constantly and the charge goes away, it still remembers. And so if charge hits it again, it'll do the same thing that it did the last time that it did. It doesn't have to learn anything.
Instant on computers with no need to upload everything all over again or save it before closing.
Right. And so what they also can't have the possibility of doing is creating a system that's able to learn in the same way that neurons in the brain learn, which the process that he's trying to mimic using memristers is called spike timing dependent plasticity. So plasticity means that it can change, but it's dependent on the timing of when spikes or incidences of electrical current hit the memristor. So the learning will take place based on the spike timing and multiple spikes coming in from, say, different synapses in different locations. And so what he's trying to do, he says, we show that we can use voltage timing to gradually increase or decrease the electrical conductance in this memristor-based system. In our brains, similar changes in synapse conductance essentially give rise to long-term memory. And so it's a really small system that he's built right now. It's basically 2 electronic circuits that are connected by a memristor. And so it's really like the spikes would come from either side of the 2 circuits of the memristor. And so And the next step is, now that it works, to be able to make something much larger, make something on the, I don't know, range of cat brain. And the end goal, he says, is to achieve the sophistication of a supercomputer in a machine the size of a 2-liter beverage container. Right now, supercomputers take up warehouses.
Do they still?
Yeah. Yes.
Really?
Yes,
I
they
thought
do.
I thought they've shrunk.
No, they're still super. Super means big.
Okay, I believe you. But maybe
Super
it's like
size
any other
me.
amount of efficiency, even though they've made the refrigerators the way more efficient than they ever were before. The compressors and everything in there, way more efficient, use a ton less electricity, but they make the refrigerators a whole bunch bigger now than they used to. Same thing with cars. Fuel efficiency has gotten better, so they've made the cars bigger as opposed to.
This is more consumer related as opposed to. Wow, that is an awesome cat picture. Thanks, John. And more consumer related than actually efficiency related. I mean, stuff like
I don't know. It
refrigerators
makes
and
it sound
cars.
like if it still takes up a
That's like,
warehouse.
look at all of our money. Look how big. That's psychological. That's like
No,
we
no, I
can
think
buy
there's probably
big stuff.
actually a warehouse where they make the supercomputer, which is only so big. And then they fill up the warehouse with the supercomputer, and then they're like, well, we can't make it bigger because we've run out of space.
I think you're it. Let it go. Moving on. Next story.
All right. This is the nominee that's about to head the Pentagon's new cyber command. Do you understand we're about to have a cyber command as a post at the Pentagon? Has testified in front of Congress last week that employing Cold War strategies to the cyber battlefield will not work. Testimony April 15th before U.S. Congress, Lieutenant General Keith A. Alexander offered his view that a Cold War approach of nuclear deterrence as a strategy for securing the United States might not translate effectively into the new realm of cyber warfare, an area where the U.S. is just beginning to truly think about strategic approaches. And there's a new study published, research paper, that concludes also that deterrence cannot serve as the primary national cybersecurity strategy, which I don't know what we would even have in terms of deterrent factor in this realm right now. So the article is in the Journal of Homeland Security and Emergency Management by University Cincinnati professor of political science Richard Harknett and co-authors John Callaghan and Rudy Kaufman. They say that to deal with cyber aggression, a more traditional model of war tactics will have to become the focus if cyberspace is to become a secure and safe place. In their article, which is Leaving Deterrence Behind, War Fighting and National Cybersecurity, Harknett and his co-authors argue that the inherent characteristics of cyberspace require adoption of a full war-fighting posture that moves out of the 50-plus year comfort zone of deterrence as the dominant strategic anchor. We must organize thinking about managing cyber-leveraged war so that damage is contained and reduced. Counterintuitively, these futuristic threats upon us require us to adopt the historical posture of a traditional warfare. So by this, they mean that we need a more, essentially we need a more offense-based framework, which is kind of an interesting thing. Who would we be attacking back? Like, who do you counterattack in a cyber attack? Do you attack the nation of its origin, or do you have to get more specific? Is it really going to be something that we can consider an active war when there's a cyber attack or a breach of security?
If it takes out a large section of, say, Wall Street or the stock market, if it throws commerce in the United States into a complete upheaval, that's a huge attack, and that I believe that would definitely be seen as an act of war. But then the question you raise also is it by a country? You have to find out where it came from. Is it a country? Is it a diffuse group of cyber terrorists? Where is it coming from? And then how do you attack them back if they're not so reliant on cyber architecture for what they're doing? If they're living in a country that, you go out into the hills and live with the goats, then whatever. How do you attack that? That's the thing. That's the question. How do you get back? Do you?
I don't know. Goats don't really scare me much, so I think I could handle that. But if they were cows, then it would be terrifying.
If they were cows, that's right.
But actually, this is what they're suggesting as part of this study, that we establish a 3-tiered, they're calling a continuum, contendum. I don't know. Basically, it's to categorize it into different categories of what the terrifying attacks are. The tiers that they've come up with in order of severity are cybercrime. So that was a frightening picture that just came up. Cybercrime, so that's like somebody who's like going after accounts and trying to get money or do online scams or what have you. Cyber espionage, which is actually doing informational reconnaissance, trying to get plans for weaponry or to get inside information about U.S. strategy.
Yeah, intelligence. Yeah.
And the other is what they would consider an actual cyber leveraged act of war, which would be not just attacks that would, like you were saying, disrupt the physical infrastructure, such as the electric grid, something like that, financial transaction networks, or disruption of communications. So the idea is, if for 24 hours we weren't allowed to use our cell phones, go on the internet, or buy something with a credit card, it would effectively take down our society. Within that first 24 hours, it would just absolutely be chaos.
Well, especially if communications were disrupted, because then how do you know what's happened? How things are moving? You just look around you and go, okay, everybody's fine, but nobody can use their cell phones.
Well, that would be
I can't buy a new pair of shoes.
That's the one. I think if you shut down the ability for people to use a credit card, you walk in there to get your latte in the morning, and all of a sudden you can't get your coffee because they can't process it because the machine is down. So you go to the Starbucks across the street and you can't use it.
And then everybody would become entirely too aggressive because of the coffee. Yeah, the lack of coffee.
You couldn't get gas at the pump because who carries cash? We don't even have cash anymore. We don't have enough cash. If you go down to your bank and try to take out like $10,000, they don't have it there. They won't give it to you. They won't. Most banks will carry like 20 grand in cash for the day to give out to people. They don't. You couldn't go and get. And then even if you went there, if they couldn't process the transaction on the computer, they wouldn't know it was your money. You don't have a little book and a stamp. They wouldn't be able to do it. No money.
I think that this is a really interesting story, though, to the point of just what are we going to how are we going to arm ourselves? How are we going to exist in a world where warfare is not necessarily the same as it has been for the past 100 years? How as we move forward, how are we going to change our tactics? And are we going back to an earlier kind of tactic, or are we, not going to rely on, we've got nuclear weapons, we have to do something else?
And it sort of is what they're saying too, is that we need an offensive strategy. But what's not detailed here, obviously, because this is the Pentagon saying that we're going to come up with a strategy, is the actual strategy. I mean, what do you attack as a counterattack in a cyber war? I mean, what is even possible then? What do we go on the offensive with? I mean, if what they're saying is that we need an ability to take down another country's grid in a way that we would be afraid of, that is an actual act of retaliation in war. That's just warfare right there. There you go. But it doesn't really seem to be a good defense even then, because as we start out talking about, the attack can come from anywhere, and more likely than not, the biggest attacks, the biggest infiltrations that we've seen, when you look at worms and viruses and people getting into financial records, hasn't been a nation attached to it, but is usually some like 14-year-old kid with a good internet connection and a knowledge of hacking that
so what we need to do, we need to cut off all World of Warcraft. Cut it off. It's done. Yeah. Other interesting studies coming out, not related to war, but still cyber in some ways, and more cybernetic, or getting to that place. Recent study that was published in Nature magazine, researchers have developed silk fibers that can be integrated as bio-integrated electronics. So they've created circuits made of silk that can be put on the surface of the brain, and in the future potentially any organ, but on the surface of the brain, and then it just dissolves away, leaving these circuits that can measure cell activity, neuron activity in the brain, and do it much better than the electrodes that are like the needle spikes. They get stuck into the brain. They can record information from more neurons more accurately and with better clarity. And they found also that it was tolerated by the brain without any inflammation in a cat for at least 1 month and probably longer. Well, now this is a really big issue because with bio-integrated devices currently, and the sensors that we currently have to use with the spikes, they go into the brain usually gets annoyed with it. Inflammation starts, and these devices have to be replaced on the order of like every month or so, or even every couple of months. But still, you don't want to be going in for brain surgery that often, right? If you want, if you're going to have a device attached to your brain,
as rarely as possible,
right? You're gonna have a device plugging into your brain. You want to go in once, twice, as rarely as possible, and you want it to work. So we need devices that can be incorporated by the brain, tolerated by the tissues, and that will last for a while. And so they're going to look at these and see how long they'll potentially last. But the researcher, neurologist Brian Litt of the University of Pennsylvania, co-authored the study, says this development heralds a new class of implantable devices. And it will significantly improve recording by conforming the electrode array to the surface of the brain. It will move forward the field of flexible electronics. And currently, says another researcher, biomedical engineer Barclay Morrison of Columbia University, currently there are no brain-computer interfaces that use such compliant mesh electrodes, and the potential is pretty big that the implant array will provide a neural interface that is stable over a long period of time, as I've said. So it's just really interesting that they've used silk-based electronics to get them to stick to the brain in this way that could be really useful for those of us who want brain-computer interfaces on our brains. Yeah.
Well, it would make life much easier. So somewhere around, I got one of those games that we were talking about where it has the mini EKG thing, and the more you concentrate, it like floats a ball up higher. It's the Mind Flex game. It's around here somewhere. I'll go find it next week. I'll try to demonstrate it.
Oh man.
It's the thing where you put on like the headset, and there's a little ball that floats in the air, and the more you concentrate, the higher it floats up. And if you like look away and lose concentration, it drops back down again. The
ball falls down. Yeah.
Yeah, and it goes through a little course and everything. It's somewhere around here. Once I get it unpacked, I'll next show, I'll do an unpaid for product demo. Right, I have on the show here. So there's been a bunch of talk this week about NASA being canceled.
Excuse me, the president canceled NASA.
Canceled it. We're done.
Man.
No more space program. President said we're just not going to do it. Well, that's not at all what happened. Not even close. What was sort of canceled to a large extent was the 20-year moon mission, moon base landing thing, which was something that was a brainchild of a previous administration, but didn't actually originate from NASA. NASA's plan actually was Mars next, and kind of got derailed for a while working on this moon thing. But it was some of the interviews we had on the show regarding this too, it was expressed that it was actually more logical to go to Mars, and that going back to the moon would be a sort of sideways venture and wouldn't be as much progress. So the new announcement that we're heading to Mars as our main goal is sort of actually back on track with NASA's previous plans. NASA hasn't been unfunded. It's still getting funded plenty. We're still gonna have space ventures. the fact that we're not going to have as many manned missions is actually the logical next step, which we've talked about time and time again, which any leader in space exploration or robotics will tell you. It's going to be robots in space
for a lot longer. I mean, we want, there's that dream of, as humans, going into outer space and getting to be the first man to set foot on Mars or whatever planet it might be. But in terms of economics, it's just not economically feasible right now to consider making missions that are manned to the moon or to Mars. Why not just continue sending robotic missions? Why not continue sending missions that will get us good information but aren't dangerous, aren't going to be putting lives at risk, will actually be bringing in probably tons more data than a human could collect, if they got there. I mean, that's, we're in hard economic times. And so choices have to be made. Directions need to be set. And yeah, a lot of people are going to lose their jobs over this, though, because missions that were planned are going to get cut. And so there's no question about that.
There's other missions that are taking their places. I mean, this isn't really a reduction of NASA to any great extent. One of the analogies of what they're about to do, the transformation they're making, is the actual launching of a lot of satellites and a lot of the missions to the International Space Station are going to be private. But the technology being used there, the mission itself, all this is still NASA. The part of NASA that's sort of getting outsourced to the private sector is as though you were a field researcher in Antarctica, and your field research team no longer operates the ship that takes you there or the helicopter that takes you into the field research site. They're outsourcing the helicopter and the boat right there, the transportation aspect of it, not the actual science, not the actual research, not the actual landers or robots. All that stuff is still part of NASA. And in fact, they are outsourcing some of that, though. And this is a story right off of the NASA.gov site. Not too distant future, a 300-pound human-looking robot might be up there.
That's right. So if we can't go, we're going to make a robot that looks like one of us, so we can maybe feel closer to it.
A little connection, yeah.
A little connection, maybe.
Yeah. And so there's going to be a GM, which I guess that's still a government operation. General Motors.
GM, robot. General Motors, yeah.
Yeah.
They've partnered with Chrysler as well for a project, I think. So it seems as though NASA is interested in getting involved with these companies that have places to build stuff.
Yeah, and a great deal of technology. There's more technology in the next car you buy, the next new car that you buy. There's more technology and computer power and everything else than there was on the first moon landing. So we really do have a lot of advancement in our vehicles, and I think it can only make the vehicles better by having them work on these more ambitious projects. So this is something there's some neat pictures of this robot, I think, up there on the NASA.gov site right now. But this is the future. This is the future of space exploration. It's going to be these robots. It's not going to be us humans. We aren't built for outer space. And as many people as there are that want to go to the moon or to Mars, I wish them well, a safe journey, and the sooner the better, because there's too many of you down here right now.
Yeah, but as they're going there,
like
researchers...
This planet right here.
You don't have to go anywhere.
Perfect. This is where I want to be. I like it.
Great. So as they're thinking about going to the moon, though, with all these robots and things, they're going to have to look out for electrification of the craters. Yeah, a computer-modeled study of solar wind flowing around the moon has found that it's actually charging the moon, so that there's actually electrons flowing over the surface of the moon in the solar wind. They rush into a crater or valley ahead of heavier ions. And so there's a separation of charge that occurs. And as a result, this can charge up, basically, and may help craters, the inside walls, and floor acquire a negative electric charge. Researchers from NASA say the electrons build up an electron cloud on the leeward side of the crater wall and floor, which can create an unusually large negative charge of a few hundred volts relative to the dense solar wind flowing over the top. And researchers are trying to, they say, develop a three-dimensional model to examine the effects of solar wind expansion around the edges of a mountain. They've examined the vertical expansion, but they want to know what also happens horizontally, and that there may also be a certain amount of effect of dust as well. And so this article from the NASA website says the team believes one possible source for this current could be negatively charged dust that is repelled by the negatively charged surface. The dust gets levitated and it flows away from this highly charged region. The Apollo astronauts in the orbiting command module saw faint rays on the lunar horizon during sunrise that might have been scattered light from electrically lofted dust. So there's some interesting stuff electrically going on the surface of the moon. And so I think probably on any planet or moon that we're looking at traveling to, where the solar wind hits it and cuts across it and around it, and it lacks an atmosphere, you're probably going to have to deal with a significant amount of static electricity, negative separation of the negative and positive charge, and potentially damage to your electronic equipment as a result. Beware of moon. It's like a giant buzzer machine.
So I'm like all government sponsored this week. This is from the Office of Naval Research. It's because I owe money to the IRS. This is my way of trying to pay it back.
I don't think it's gonna convince the IRS.
No, they don't care. They're heartless. The Office of Naval Research is doing some very interesting things with alternative fuels, specifically this microbial fuel cell that they've developed. This is pretty interesting stuff. Microbial fuel cell research is a great example of naval needs propelling advanced technology that is also a potential benefit to the public, says Chief of Naval Research Rear Admiral Nevin Carr. Yeah, so this is something I didn't realize. They've already developed some sort of deep sea sensors that they can put out there into the ocean that create their electricity, their fuel, out of microbes that were found in the water.
Whoa.
And one of the ones, they've actually engineered some that they found apparently just a couple miles down river in the Potomac. That what did they call it? The geobacter.
Yeah.
They found this little guy, and they has these hair-like extensions, the pili, that generate electricity from mud and wastewater. They developed a strain of them that is 8 times more efficient at producing the power, and they're now using them as fuel. But they're also looking for. They said one of these can last for years and years without any kind of replacement. And they've actually got sensors out there already in the ocean that are monitoring temperature or what have you, that are using existing bacteria, microbes in the ocean water. That's amazing.
That's awesome. Yeah,
and
that's
one of the projects they're working on is I guess it's a 4-foot long autonomous underwater vehicle, a little ocean robot, probably spy bot that will cruise around, and when it starts to run low on fuel, it just sinks to the bottom. It goes down to the bottom, to the muddy bottom, where there's a high concentration of decayed microbes and microbes themselves, and collects them, and then they're fueled again. And
that's
so
great.
Robots in space, robots in our oceans too. Woo!
I love it. Well, speaking of
go ahead.
I was just going to keep going because we're kind of running out of time, and I have a couple more stories that I wanted to get to because I teased them at the beginning. So I'm going to push ahead. Lightning on Saturn. So it's not electricity from microbes at the bottom of the ocean, but it is lightning on Saturn. And the researchers say this is the first time we have the visible lightning flash together with the radio data. and they've lined up the radio and visible light data, and they know for sure that they're seeing powerful lightning storms on Saturn. So they take a whole bunch of pictures because they don't actually have like a moving picture camera. So they've had to take a whole bunch of individual pictures to create a movie that looks like it's a complete movie. And they have a soundtrack as well that features the crackle of radio waves that are emitted when lightning bolts are striking. And the reason that they can get that is that the Cassini probe is able to pick up the static from the electrostatic discharge signals because it has radio and plasma wave science instruments that are sensitive to the kind of static that you hear on an AM radio. So these lightning flashes are emitting radio waves that can then be picked up by Cassini and then sent back here so that we can actually hear Saturn lightning. But I guess it's not quite like a lightning storm here on Earth in terms of what you hear in the sound. But anyway, so they're able to look at these lightning images, visible light images, and able to be able to get a measurement of how big the clouds are, how intense the storms are, where they're forming in the cloud layer, and be able to try and get an idea of how similar the storms on Saturn are to other places and the dynamics of these storms that are happening. I mean, already they know that the storms are huge, immense storms that are so far beyond anything that we understand here on Earth, that they're just immense things.
In smaller news, chickens. Antibodies. Bringing it all back around to antibiotics. This is from the International Vaccine Institute. Scientists have discovered for the first time, which is like, by the way, that's the header of about every single press release that's ever created by any type of organization or research team. Scientists have discovered for the first time, because if you're discovering it for the second or third time, I guess it doesn't count, have discovered for the first time that antibodies in common eggs laid by hens vaccinated against the H5N1 virus can potentially prevent the possible H5N1 pandemic, raising the possibility that the same principle could be used applied to the current H1N1 influenza pandemic. So it's kind of an interesting idea that most of our vaccinations. Now, most of our vaccinations are created in eggs. This is actually
right, in chicken eggs, yeah.
Right, which has been one of the problems of the avian flu, is that it affects birds as well and can harm them. So then, is it going to, But
right, is it going to affect the chicken egg? Will it affect the vaccine? Is it going to make it easier for us to catch whatever the flu is? Is it going to be bad for us? But now they're finding that no, it's not. It's good.
Yeah, but what they're finding is that hens that are vaccinated are creating eggs that are immune, and that the antibodies for the immunity are already in those eggs, which is what we would normally suss out to use for something else. So the idea is, if we can come up with a chicken that's immune to the H1N1, we may have by proxy created the
egg that's immune as well.
Yeah.
But you can't make the egg immune first to have to get the chicken first. So, yeah, so I guess the chicken did come first in this situation.
The chicken's coming first, finally. We've been trying to put the egg first all along, which I've always said the egg had to come first because the egg predates the chicken. But yeah, chicken antibodies can be administered by nasal spray. So as a form of passive vaccination, it can be applied to prevent diseases caused by the current H1N1 using egg yolk antibodies from hens vaccinated against the virus. Interesting.
That's cool. Speaking of other eggs and disease, this is my last story for the show. Scientists at Newcastle University, Dr. Mary Herbert and Professor Doug Turnbull, have created, they've published a proof of principle that we can potentially cure mitochondrial diseases. So what are mitochondrial diseases? Mitochondrial diseases are diseases that are passed on from mutations in the mitochondrial DNA. Now, mitochondrial DNA comes from the mother's egg. So the sperm doesn't have any mitochondria in it. You have two sex cells. You have sperm and you have the egg, and the sperm has its nucleus in it, and it's just powered up and just ready to get itself into the egg. The egg has mitochondria. It has a whole bunch of other cellular organelles inside of it and the nucleus. The sperm will end up inside the egg, and then you have the two nuclei that will end up coming together to give you the double component of chromosomes that we need to be human. X and the Y, or the X and the X, whatever it might be for you. Now, mitochondria then is only passed on from mother to child. And if there are any mutations in it, those mutations will get passed on to the child. And so looking at statistics, numbers of people or numbers of children who get these diseases, where are the numbers here? I had some numbers. Around 1 in 200 children are born each year with mutations, which usually are very mild or asymptomatic. So 1 in 200 is pretty big with mutations, but 1 in 6,500 children are born with severe disease, which is caused by the mutations. So this is muscular weakness, blindness, heart failure, liver failure, learning disability, diabetes. Any of these could potentially lead to death early on in life. So what do we want to do? We want to cure this. And what have they done? They've created this proof of principle where they basically took a fertilized egg from a female, and they took a fertilized egg from a donor. And then they took the nuclei out of the fertilized egg from the female, and then took the nucleus out of the donor's egg, and then stuck the female's nucleus into the donor egg, because the donor egg had the healthy mitochondria in it. And then they let those fertilized eggs that had the donor nucleus removed and the woman's nucleus in, they let them grow into blastocyst stage. They created 80 zygotes or fertilized eggs from this procedure, let them all develop. And they found that many of them divided into healthy blastocyst stages, proving that this could potentially lead to an in vitro fertilization method that would give a parent the ability to choose. If they knew they had mitochondrial mutations and the potential for passing those on to their children, would give them the ability to choose prior to starting the process of deciding whether or not to have a child, whether or not they could have a healthy child, as opposed to taking the chance of having a child that might die. So this is engineering, human. That's right. Human engineering on the way. It's awesome. I'm really excited about this. It's and this is all for anybody who has any concerns about whether this is done with regard to regulations. This is all according to procedures that have been set forth for years since people first started working in IVF and stem cells. So this is all legal, and everything is under license. So
whatever.
I think it's great. I mean, as opposed to I think I have to have an abortion, I can't deal with it, whatever, I'm gonna have a baby that's gonna die. Now there's a potential choice to have a healthy child, which is awesome.
That's pretty groovy.
I think it's pretty groovy. So we're ending the show on a very high note, I think.
All right, thank you everybody for tuning in again.
On next week's show,
pixelated again. I'm becoming more pixelated as the evening goes on.
That's right.
Look at this. I'm fading away. Maybe a new camera next week.
We're moving further away from the camera as it's gone on as well. On next week's show, it's going to be more and more science as always. But in the meantime, don't forget to donate to KDVS in support of freeform radio and a decade of This Week in Science. Fundraiser.kdvs.org/premiums/specials/show/TWiS. Shout out.
We're gonna be there all tomorrow morning. So yeah, we're gonna go to bed.
Yeah, we're gonna be live on the air
early.
tomorrow. We're gonna be doing the show live and trying to get people to donate. So Yeah, it'll be fun. Shout outs to Ed Dyer, Artyom Dioktev, Andrew Peterson, and Richard Baker. Thanks, y'all, for sending emails and all of the help. Ed Dyer gave me so many stories this week. I just want to say he was on my wavelength. He totally was. Props.
Yeah, shout outs to Pamela Sue Taylor in the Land of Oz. She's been updating me with plenty of stories as well. Minnie and Scott, who sent in the yummy breast, the good for your health breast story, which has now justified all of mankind to ogle away for their own perseverance. I'm just doing it for my health. That's all there is to it.
That's right.
For any information, more information on anything you heard today, Allie, who may be watching or paying attention, is going to have show notes that she'll put up to our website at some point tomorrow.
That's right. And our website is www.TWIS.org. And you can also go there to subscribe to the podcast if you haven't done that already. There's a little button that says subscribe to the TWIS Science Podcast, and it'll give you information on how to subscribe. Or you can just search for us in iTunes.
Yeah, Google us on the iTunes. That's where you can find us the quickest.
Right.
So yeah, or you can reach us at the websites. The emails. You got Kirsten at This Week in Science, Justin at This Week in Science. That's your direct link. But you got to put TWIS somewhere in the subject or you'll get spam filtered. And we do want your feedback. So if there's a topic you would like us to cover or address, subject or suggestion for an interview, please let us know.
And we will be back here next week. And we hope that you'll join us for more great science news.
And if you have learned anything from tonight's show, remember,
it's all in your head. And that's a wrap.
Cue the music.
And kittens.